All right, well, welcome to multi-body versus assembly modeling techniques, and it's kind of just what it sounds like. We're going to talk about both extensively, but Jim said I could tell my nerdy joke, and this is like the only place that everybody will get it at the same time. So anyway, Einstein, Pascal, and Newton walk into a bar, and they actually don't walk into a bar. They're sitting around and they decide to play hide and go seek. So Einstein says, I'll be it. So he goes off in the corner and starts counting, 1, 2, 3. And Pascal just takes off. He goes to try to find a place to hide. But Newton just stands there. And he just stands there and he stands there. A minute later, he takes out his chalk and he draws a square on the floor. And then he stands in it. And the square happens to be 1 meter by 1 meter by 1 meter squared. So he just stands there inside that square, and then Einstein is finishing up, 99, 100, ready or not, here I come. And he turns around, and he sees Newton standing there inside the square. And he said, Newton, I see you. He says, no, you don't see me, you see Pascal. 1 Newton per square meter.
They all get it.
Only place I could tell that. Okay, so we're going to try to answer the question, should you guys create the model in a part, an assembly, or a combination of the two? And I guarantee we'll answer that question at the end.
Okay, one thing that's important here is we're not going to tell you specifically, do it this way or do it that way. This is a compare and contrast type of presentation. And that's why any of you sitting too close to the screen, if you can't see both sides, you're going to miss something. Because we're going to be showing different things on both sides so you can see them live at the same time. So
that means you guys right there.
So the hope is when we're done, you can better figure out for yourself how to solve your problems.
And we've got to get our button pushes in sync here. So for those of you that don't know me, my name's Phil Sluter, and I'm the owner of Triaxial Design and Analysis, an engineering services company in San Diego. I've been using SolidWorks since release 96, certified SolidWorks professional and a certified instructor. I've done a lot of other presentations here at SolidWorks World, so you might have seen my other presentations. And Jim and I have actually presented at the San Diego SolidWorks user group together on and off for the last 12 years, 14 years.
Something like that.
So we kind of know each other a little bit.
And my name is Jim Boland. I'm a PE and a CSWP, and like Phil, I've been using SolidWorks since the last century. My day job is writing training manuals for SolidWorks, where one of the books I wrote is creating animations with SolidWorks. And I've presented here at SolidWorks a couple of times before. And just a plug for tomorrow, if you like this compare and contrast type of presentation, I'm doing one tomorrow on composer versus animator with Callie McMillan from Go Engineer.
All right, so here's our design intent for our project. We're going to do a little project here. We're going to build a plastic box, kind of looks like a tackle box, and it's going to hold a circuit card in it. So it's kind of a silly scenario, but this is what the customer wants. You know how those pesky customers are. And we're going to make it so we can change the card size, we can change the size of the box. We're going to use a couple of purchase parts, recessed handle, a lid, a latch, an over-center latch to secure it in the front. So there's several things we're going to add to this box, and we're going to try to do it both in multi-bodies and assemblies.
And while we build it, we're going to be given a couple of components, so we're not going to build everything. The key component here is this circuit board, because that's what we're trying to build the box around. The problem is the circuit board isn't done yet. So we kind of have a vague idea how big it is, but we don't really know the final size. And the handle and the latch are things that we already have, and we'll just insert them in to whichever method we're using.
Okay, so it's not just going to be about the picks and clicks. We've got a script you're supposed to be following, and I'm probably not following it.
You're good.
Okay. So it's not going to be about the picks and clicks. We're going to try to focus on why you would use one method over the other. So things that are going to influence these choices are going to be heavily the design requirements, the amount of change you anticipate on your project, which you can't always anticipate the change, but might be there. A deadline, that's very important. Is it in 2 hours for a meeting, or is it in 3 months for a customer presentation? The deliverables are very important. Are you going to be just making some SLA models or some 3D printed models and maybe adding some inserts to it and sending it off to the SLA house, or are you going to be have heavier design requirements? And the documentation that goes along with that. Is it a formal drawing or what? So those are the kind of things keep in mind as we're doing this, that there's going to be deliverables, and that's the kind of thing you're going to base your decisions on, whether to do one or both. So I'm going to take the multi-body side. So you guys are all multi-body fans over here now. And our scenario is to make a quick concept for marketing. Meetings in 2 hours. We're just going to make some prototypes for the 3D printer. We're probably going to have to tell them how to manufacture it, maybe what colors to paint it. So we're going to need just a little bit of minimal documentation. But it's going to be very limited production span, maybe some silicone molds, and maybe get 20 more parts, but that'll be about it. And so that's kind of our scenario with the multi-body.
Okay, on the assembly side, it's a little bit different, but also notice the screens are slightly different colors. That will also follow through when we go into SolidWorks, that we'll use backgrounds that are similar, so you can always tell that multi-bodies is over there in the light green and I'm over here in the tan color. Now for assemblies, the design scenario is a little different. We've got a little more time to design this, but we're not just making a couple of quick prototypes. This is something we intend to produce and make a lot of copies. So it's going to be a high volume project. We need to make sure we have revision control on the project, and documentation will be far more rigid. We're probably going to have to put this into a PDM system. In the end, all parts need to be standalone parts. So we're going to get rid of any in-context references so we don't have any fear of a part changing accidentally on us.
Okay, so specifically the deliverables for the scenario one, my scenario, are going to be some minimal drawings. We need to send off the files for rapid prototyping. We may have to do some analysis later on, and maybe some moldability, to get some quotes for later on. And we may have to do some rendering and animation. So we got to keep those in mind. That's all we know right now.
On the assembly side, we're going to have to do drawings. There's going to have to be files for manufacturing. So we want to make sure everything's a standalone part. PDM is definitely going to be used. Analysis, again, we may have to do the analysis. We're not sure yet. We definitely will have to do an animation of this thing and probably a rendering.
Okay, so let's talk about multi-body for just a second. Multi-bodies are a way to describe different components within the context of a single part file. And those parts could represent different manufactured parts. Top and bottom of our box is a good example. But there's a couple of different techniques you can use within that context. The two main, there's like weldments, where everything fits together in one part, and they all have separate bodies, but there's not really any flow between the two parts. In other words, you don't need to put them both together in the same part file to get a smooth shape between your parts, okay? And then the other method is when you do need a smooth shape between the two parts, like a mouse or something like that, and I've got some examples here on the next slide, but where things have to flow between all the parts, okay? Curvy surfaces, swoopy surfaces. So that's the kind of method we're going to use here today. We're going to build it as what's called a master model technique. And in reality, when you really start doing this stuff, it's probably not going to be either or. I mean, a guy just gave me an example, said, can I do my progressive die stuff all in one single part file? And I said, well, it might be better to break it up. So some of the components are multi-body parts, and then you take those and put them in an assembly. So there's a lot of different in-between scenarios. Just like it's not, the multi-body part isn't just the master part and just the separate bodies. You can combine those as well. So there's a lot of choices there. So here's a couple of good examples of master part technique or master model technique. Both of these components were made starting out with a master model. The part on the right is the blue and white one. That one, there's not a straight edge on that entire part. The part line's not straight, nothing's straight. It curves, it dips down, and that was created by creating both parts in one single part file, and then later on we took it out to an assembly. Same thing with the larger piece over on the other side. If you look real carefully, I'll try to point to it. Right down in here, you can see one of the surfaces between the two parts was actually one surface to begin with, and then we split it apart so we get a nice smooth flow between those. And both of these parts were actually in production today, and they were all started with that master model technique. Okay, even the moving parts and things like that. So that's a good example of what we're going to try to show you today. On this side.
On the assembly side, most of you, when you first learned SolidWorks and made an assembly, you did a bottom-up approach. And the bottom-up approach is pretty much the erector set approach. You have individual parts and you're going to put them together. But we also have top-down design where we can create parts in the assembly so they reference other parts. So that if you had to make a part that spanned between two other parts, instead of just building this part separately at a certain length, if in a case like that, if we moved one of the ends, you'd have a gap. But if I build it top down, I can actually have the part always go to the other part, and if I move the outside parts back and forth, the middle part will adjust. So we'll be using those two techniques over here. When we do top-down design, we create a lot of in-context references, which we'll talk about, not only how they're created, what they are, and how we get rid of them at the end. But it's also important, just like we did on multi-bodies, that top-down, bottom-up are not mutually exclusive. A lot of assemblies have both of them combined in the same assembly. Okay.
All right, so these are some of the differences are going to be. A lot of things are going to be very similar, but some things are going to be different. So you're going to see some differences in how we do in-context things. In other words, how we relate one part to the next. That's going to be some big differences. Insert part versus insert component. Just like Jim can bring components into his assembly, I can bring components into my part as well, and you're going to see how to do that. We're going to see different ways to share and copy sketches. We're going to have to use different techniques to reuse those sketches for both the multi-body and the assembly. Assembly motion versus move, copy, and rotate. That's going to be one of the real interesting ones because, well, you'll see. Anyway, we're going to compare those two directly. Exploded views, we're going to compare those, and then we're also going to compare bill of materials versus a cut list, and those will be similar results. So it's going to get real good. Okay, for just this once, I'm going to talk about that slide, and Phil's going to talk about this slide. When we do this design, we're really going to be talking about two things. We're going to start talking about how we build it and the mechanics of building the box. And the other part of this, which Phil will hit the bullets on the other side, is did I change those back? Yeah. The other thing is the effects of our choices, which is significant. And that's where we think the real value added here is. Not just how you do it, but the effects. So we're going to start by creating the box. Pretty straightforward. We're going to build the bottom, build the top. They always have to fit together, so they always have to be exactly the same size. We're going to need to do a lip and groove in here to connect the top and the bottom. Got to put a hinge and a hinge pin in there. There's a handle that goes in the top of the box and it fits in a recess. Then we finally have to get in and put in the printed circuit board and mount it on the inside of the box. And we have to do all this being able to adjust the box as the printed circuit board changes. Okay, and then after we finish the boxes, then we're going to do other things to it. We're going to add materials to both of them. We're going to have to lock some mates and lock some references. We're going to show some animation and some motion or something similar. We're going to show a drawing with all the stuff you normally put in a drawing. We're going to talk about save bodies and create assemblies from the multi-body, because that's a very important way to get your multi-body part. When you're all done, you have to turn it into an assembly sometimes. So we're going to show you how to do that. then Jim's going to show how to break all those in-context references, because remember, one of his deliverables was he needs to separate out all the parts into individual part files and make them stand alone. And then I'm going to show you just a couple of more tricks on what to do with your, after you save your bodies into an assembly, how to turn it into more of a real assembly.
Okay, as in any design project, before you just start clicking the mouse, you have to put a little thought into the project, and there's two key items we want to discuss here. One, we want to make sure we can maintain parametric design as long as we can, because until we know the final size of that circuit board, we may have to change the box size. And when we change the box size, we'd like to be able to just go click the length and the width someplace, and everything else should just follow through. We don't want to get everything individual where we start playing chase the dimension. The other issue is, where does the assembly go, or the assembly origin go, and where do all the planes go? And we'd like to make sure that all the parts are lined up the same way. As your assemblies get bigger, sometimes that's really nice to have all the front planes parallel to one another, right planes parallel, and top planes parallel. And we'll build the parts that way. So with that, we're going to start building.
Okay, so let's start with the multi-body. Oops. Where'd you go? There you are. Okay, so we're starting on a plane, and we're just going to build a boss first. Okay, and we created a sketch that just looks like the outside shape. Significant things on that is it's 12 by 6.5. It's got some radiuses in the corners, so when we extrude with draft, we're going to get kind of a tapering radius. But I'm extruding both sides at the same time, going up to the top and down to the bottom, okay? So we get those shapes, and they're both going to change together because it's both the same sketch, right? So that's easy. Then we're going to add a fillet around the top and bottom. Now the significant thing here is it's the same fillet feature. So we don't have to do anything fancy to connect the two values together because it's the same body. We haven't split it into two bodies yet. And then I'm going to go ahead and shell it. And I didn't pick any surfaces to remove, so what we've got is a hollow shell now. Okay? And there's a million ways to do this. This is just the way I chose to do it today. And then I'm going to add a boss all the way around the outside. Still got one body, but I've added that boss because that's going to be where our lip and groove is eventually going to go. And then I'm going to finally split it apart. And the way I'm going to split it apart is using a new 2013 command called intersect. So we're going to go to Insert, Features, Intersect. And the way this works is you pick things. And one of them has to be a solid body, so I'm going to pick the solid body. And I want to split it apart with the top plane, so I'm going to pick that as well. And then you go ahead and tell SolidWorks to intersect the two. And it came up with 4 regions that it allows us to pick and save, okay? So the 4 regions are going to be the top of our box and the bottom of our box, the inside of the top of the box, and the inside of the bottom of the box. Okay, so we don't need the 2 on the inside. But right now, really, the easiest things to pick are the 2 outside. So I can pick this, and I can pick that. And so that's the 2 top and bottom of our boxes, right, that are split by that plane. But notice what it says, regions to exclude. So if I go ahead and say, okay, it's going to exclude those 2 that I just picked, and we're going to end up with the inside of our box. And we don't want that. So I'm going to invert the selection, and now it's got the 2 insides selected. And that means it's going to remove the 2 insides. Okay, so now we're not quite ready, because now if we say okay, it's going to merge the top and the bottom together, and we'll end up with exactly what we started with. So we have to uncheck merge result, and now we're going to get 2 bodies, the top and the bottom. And if we look at the section view again, you can see that it's actually split them in 2. If we come up here and look at the solid body folder, we've got both bodies. So now we finally got a multi-body part, okay? So that's our start.
Okay, on the assembly side, I'm going to build the bottom just as a plain old part. Anybody can build a box. So I'm going to use a centered rectangle. I'm also going to put sketch fillets in here. Now, some of you will argue, said, well, why are you going to use sketch fillets? Why don't you just use feature fillets? We could, but somehow we're going to have to link them to the top of the part. So I'm going to use sketch fillets here, but I'm also going to use a feature fillet here in a second, and I'll show you how both of those are going to translate over to the top of the box. One other thing that's done in here, just so you know, I've renamed a couple of dimensions just to keep them all straight. So there's really a length, a width, and a corner radius, which will come into play in a while. With that, it's just an extrusion, 3 inches, 3 degrees of draft, put a bottom fillet on it, and again on the bottom fillet there is a name on that radius. Shell it out, same as fill, no big difference there. To make the lip boss all the way around, did it a little different than Phil did it, because in this case we just used the sketch, and it's just a little box. If you're going to sweep around the edge of something, it's always a good idea to make sure you have contact all the way around, so that's why there's a construction line in here, and that just gives us the boss. Now to that, I'm going to go and into the assembly. And now we have to build the top of the box. So you notice I'm in an assembly now. The top of the box has got to match the bottom of the box at all times. So I'm going to build this top down. And to do that, I'm going to insert a component. Yeah. Insert component, new part. Now if you've never done this before, the cursor's got a little check mark. What it's saying, this is a new part. Where's it going to be located? Whatever flat face you pick, that's going to be the front plane of the new part. Well, I said earlier I want the front plane of all the parts to be parallel to one another, so I will go in and I can just use the front plane of the assembly. Okay. Now I'm in the edit part mode, but there's no geometry just yet. And I'm in a sketch, that happens automatically, but the sketch I'm in is on the front plane of the part, and I really want to put it on the top plane of the part so it matches the top of the other box. That's easy enough, just get out of the sketch and create a new sketch. So in this case I want to start on the top plane of the new part. I want this sketch to look exactly the same as that sketch on the bottom of the box. Well, I can see that in the assembly up here. That's the boss, there's the sketch, and if I just do a convert entities, this sketch will now do exactly what the sketch on the bottom of the box did. Okay, so I can take that sketch and then I can extrude it and roll this over, but I'm going to end right there for just a second and get out of this because I'm going to skip ahead. Before I do that, notice the part I made has got square brackets on it. It's got square brackets because it's an internal part. In other words, it's not a separate part file yet. You can think of it like in the Microsoft world, linking and embedding. Usually we link all the part files to the assembly. They're not actually internal to the assembly. This right now is an internal part. It's like an embedded part. We don't like that. We want a separate part file, so there's two things you do in here. If you right-click on it, you can rename the part, and then you can also then save the part in an external file. Like I said, I'm not going to do that. I'm just going to delete that part.
See how much more trouble it is to do it in the assembly?
Yeah, just wait.
Yeah.
And the reason for that is I've already built all that, because at this point, shelling is the same, putting the lip boss all the way around is the same, so I now have a top and a bottom. But you should also notice at this point this little arrow here at the end of the part name that says there's an in-context relationship. And in the assembly, if we go up here and say show update holders, there's an update holder in the bottom. And what that is, that's the link between the two parts. That sketch in the bottom is linked to the sketch in the top through the assembly. It's important to understand that. It's through the assembly. And the place it goes through is right there in that update holder. Okay, now, we're still early in the design here, but I just wanted to show you something else we can do that Phil can't. And that's, we can actually animate this. So if I go back to the assembly, sometimes you got to deal with those pesky marketing folks, and they want to know, is this, can it be a little bigger? Can it be a little wider, a little taller? Can the fillets be a little rounder? Well, we can actually animate this. So some of you may think you can't animate parts and part features, but yes, you can. And by the way, you're watching annotations change here dynamically. And the nice thing is I can now go grab the cursor in here and I can move this box around. So if you're standing in front of somebody and say, oh yeah, you want a little taller, a little shorter, I can do that. And then just read the numbers off. So that's doable. Okay, one other thing I needed to show you here. We know that the top and the bottom of the box have the same profiles. And that's why that sketch fillet in the first sketch is controlling this radius down here, but it's also controlling this radius up here. But how about this fillet and the fillet on the bottom here? I still need them to be the same. Well, in the assembly, I can just add an equation between the two of those. It's just an equal equation, and that's one of the reasons I renamed all those dimensions. So there's a dimension called top fillet, or as part of the box top, is equal to the bottom fillet and the bottom part. So whenever I change the radius of the bottom fillet, the top fillet is going to change as well.
What about your shell?
If we thought the shell was going to change, I would do that. We're considering that the shell thickness isn't going to change. But yeah, that's part of the, what you're given for your design. And we're going to see in a minute when we get to the hinge, there's some things that we're not going to make exactly parametric because we know they're not going to change. No matter how far the box changes, the hinge is always going to be the same size. And
all right.
We're back to you.
Okay, so let's keep going on our multi-body part here. So all we're going to do right now is add a lip and a groove. Okay, so we just come up to our tools, insert, fastening feature, lip and groove. And what it wants to know are what are the two bodies you'd like to put the lip and the groove on. So the top one is going to be the lip, and then it jumps down and says where do you want to put the groove, and we're going to put it there. And then it asks what's something that's perpendicular to all that, so we'll know which direction to put it in, and I'm just going to pick the top plane again. And then it automatically jumps to the groove. I might have got those inverted a minute ago. So the groove we want to put on the top, so it wants to know which surface do you want to put the groove on, and we want to put it on the underside right there. And then it wants to know which edge do you want to put it, inside, outside, so we're going to put it on the inside. By the way, if this ever confuses you, just pick the surface, pick the inside, pick the surface, pick the inside, and it'll generally work. And then the same thing for the bottom. This is where we want to put the lip, and we want to put it on that surface, and we want to put it on the inside again. So it's going to build it all up. It remembers your dimensions from the last one, or you can save it as a favorite. And it's remembering the correct numbers, so I'm just going to say OK. And it quickly adds a lip and a groove. And so now we're done.
Okay, on the assembly side, it's pretty much the same thing. The one difference is we're going to start the lip and groove feature by editing one of the parts. So in this case, I had picked the bottom part and said edit part. And pretty much everything else from there was the same as Phil's, except now we have to look at something because we actually learned something doing this presentation that we hadn't understood before. If you look at the lip and groove feature, here's the lip and groove feature in the bottom. It's just a standalone feature. But if you go to the box top, there's an external reference. This is going to come into play later when we start trying to break all these in-context relationships. So the feature really belongs in the bottom part, but it's linked to the top.
And that's one thing I neglected to mention. If you notice on my feature tree, there are two features. And it splits them up, but they're tied intimately together. So that's one thing we're not going to try to do on the multi-body side. We're not going to try to, separate everything out. Because when you get to the lip and groove, you're going to have really bad luck trying to separate it out or delete one and not the other. So it's kind of equivalent to the assembly. You've got two features here. Over there you've got two features, but they happen to be spread out over two parts and tied together through the assembly file.
Okay, the next thing we have to tackle is putting a hinge on this. Now, as one of the earlier questions indicated, why we didn't link the shells together, the hinge is kind of the same thing, that we know the circuit board is only going to be within a certain size range. We don't know exactly how big it is, but it's not going to go from this big to this big. It's going to go like from this big to this big or this big, so it's going to stay relatively small. So understanding that, the hinge we create is going to be the same size no matter how wide or long the box gets. But we have to account for the fact that the box may get wider, which is going to push the hinge further back from the origin. And the way I'm going to approach this, whoops, too fast, is I'm going to use a couple of sketches that are going to be used in both the top and the bottom part. Now, when we do this, I could make blocks out of these sketches to insert them into both. I could insert this sketch into the assembly and then through convert entities take it into the parts. But I'm not going to do that. I'm just going to actually just put this same sketch and copy it into both the top and the bottom parts because it's got to stay the same. The only unique thing about the sketch is the length of this line from here to here. Because when I put it in the part, this is going to go on the origin of the part, since that's where the hinge line is, really, because I created that on the top plane of the part. All this geometry down here has got dimensions on it, so it stays with a fixed relationship. And it's fixed to this point, but the distance from this point to this point is undefined. So when I drop it into the part, this goes to the origin, and this point goes to the edge of the box. So if the box gets wider, it just drives the sketch back. The other part is I'm going to use those sketches to make the long extrusion along the back of the box, but now I got to chop it up because hinges work like this. So I have to cut away alternate sections. And to do that, we're going to use another sketch just like this. I'm going to drop it into both parts. Again, the origin goes here, and any one of these corners will drop to the end of the box. So this whole rectangular section will move with the depth of the box. Now we use that as a pattern so that I can then create rectangles around these. Well, why am I doing that? Well, because I'm going to go in and dimension these, just a little offset. And what you're looking at here, this is the way I'm going to cut the top of the box. I'm going to cut away these four rectangles. What's that going to leave us with? It's going to leave us with a piece here, here, and here. And using the same start sketch, in the bottom we're just going to cut away the other pieces. Now, why these little overlaps? Because you don't want the pieces of the hinge to butt up against one another. You really want a little gap. So these were all dimensioned to the outside of that construction geometry. So if you cut this one to the outside one way and the other one to the outside the other way, you're left with a little gap between them, which we'll see in just a second. Okay, so I can just open the bottom box by itself because I really don't have anything to do in context here. Let me just unsuppress the first component. There's the long extrusion. It was made from this sketch. And if we go to the right-hand view, if we look at the way the extrusion was created, if those of you know how to select contours, we just used part of the sketch and basically took this and this, extruded it. When I go to the top, I'll use this section up here plus the circle. And we know everything's going to line up. Then we go to the top view and we take that other sketch I showed you. There's the sketch. And I'm going to cut away these boxes, which gives me that. We go back to the assembly. Okay, there it is. And do the same routine on the top of the box. We get the other half of it. And now you can see the little gaps in the hinge just so the hinge will move without rubbing. What's left? Got to put a pin in it. I'm going to do this a little different than Phil's about to do it. I've already got the part created. I can just drag it over here into the assembly, and then we can just mate this into the hole. Oh, come on. Yeah. Then move it in close enough. Okay, move. There we go, closer. Okay, grab that, hit the Alt key, drag it in there. Get that face, hit the Alt. Come on, go to that one. Yeah, fine. Looks like I didn't catch my other mate here.
You get the idea, right?
Yeah.
Yeah.
On, there it is. Not that I haven't done this before. Okay.
All right.
Okay.
So let's do ours now. Ours meaning ours on this side.
Sure.
Let's see. We want to open up a file, and we want to open up 3. So we're going to use the same sketches. But what's different with ours is when we extrude the half of the hinge to start with, we've got to specify which half we want our extrusion to go on. For instance, if we are doing this feature right here, we're extruding the top part, we've got to specify that we want it to go on the top half of the box. We don't want it to merge with the bottom half of the box. Okay? So we're going to unsuppress that. So that one's merged to the top. The bottom one's merged, the bottom one's merged to the bottom half. So we still have 2 bodies, but the hinge halves are merged to the proper top and bottom. But we still have to cut it, just like Jim had to cut it. Now, so there's his outline sketch. We're actually using the exact same sketches. We put them into a library feature, and we're using them. Then we made a cut on the top and a cut on the bottom. Okay, now there's one more thing. When we cut, we got to make sure that I've got my gaps to adjust. Let me just, that reminds me, I was going to show you one other thing. So when we go to this sketch, the way Jim was talking about, we've got to dimension these things. And why is that fixed? I don't know. But when we add a dimension to these, there's a little trick you can do, and I showed this in tips yesterday. If you want a number that repeats, just pick another dimension that has the correct number on it, and it'll just jump right to it. Add the dimension. When it asks you for the value, just pick the other dimension. And just keep going. It makes it real easy to dimension things the same.
Phil, does that create a length value, or is it just top?
No, it doesn't. So if you wanted to link those, you'd do it, the normal methods. But it makes it real easy to put a whole bunch of things at the same value. Okay, so now when we cut these away, the trick here is we had to specify the body we wanted to cut because we don't want it cutting through both. So you just have to pay attention. There's another little trick here. If the body that you want to cut is showing, in other words, hide and show, if it's showing, and the other body is hidden at the moment you're trying to cut through it, it won't cut through the hidden one. It'll just cut through the one that's showing. So if you want to think about it that way, or if you want to just come down here and specify what you're cutting through, that'll work too. So basically, I just did the same thing Jim did. Oops.
I didn't do an oops.
Well, that oops is from my AutoCAD days, right? Remember the oops command in AutoCAD? So we've got our hinges, but we don't have a pin yet through it. Let's go back, and we're going to edit this sketch. And if you remember the sketch, not that sketch, this sketch. We edited this sketch, and I actually added the circle, and I actually did a cut with that circle to get rid of our excess material. So that got us to this point, and then I actually extruded another feature, both directions, mid-plane, but I did not merge it with anything else. So now we're going to have 3 bodies. We're going to have the top, the bottom, and the hinge pin. And they're not merged, and then I just added a chamfer on the end so you could tell it was a pin. So now we've got 3 bodies in our part, okay? All right, then we're going to add another feature, okay? The next thing we have to add is the handle for the top. If you remember, it kind of looked like a tackle box, and there was a little recess in the top, and then we dropped in a handle that flopped from side to side, okay? So the way I'm going to have to do that is we're going to bring in a library feature. It's right here. First, we're going to cut out the recess with a library feature, and then we're going to add a part into this part. Okay? But we have to get it before the shell because we want our recess to be before the shell. So I'm just going to roll back before the shell, and I'm going to find our library feature, and it's this recess right here, and I'm going to drag it and drop it right on top of my part. It needs to know where the origin is, and it also needs to know where the right plane is, but it needs to know twice. You have to pick it twice, right? And then we've got it positioned right, and we're all set. So there's our recess, okay? But remember, we're rolled back before the shell, so now we're going to roll back, or roll to the end. And we've still got three bodies. We've got the top, the bottom, and the pin still, but now we've got a recess in our top piece, okay? Now we're going to bring in the handle. So this is where it gets a little tricky. The handle is an existing, maybe it's a purchase part or one you used on another project. How do we bring that in? Well, it's just called insert part. So we're in a part file, we're going to insert another part. The part we're going to bring in is called handle. It's a pre-finished part. Jim's going to use the exact same part file. Bring it in. Okay. The terminology or the vocabulary for this is a little confusing, but basically we're going to position this after we insert it. Okay? So I'm just going to throw it out in space there. And then there's a couple of different ways to locate it. We can translate it from where it is now, we can rotate it from where it is now, or we can use something called constraints. And when you go to constraints, it looks like mates. Matter of fact, it calls it a mate right here, but that's part of the terminology deltas there. So we want to just use a concentric between this cylinder, and it jumps down just like a mate would. And we're going to add that to our feature set. And then we also want to make this right plane here. We want that coincident with the right plane of our entire part. And it jumps over. And then just so this looks a little more realistic, we're going to add one more. We're going to make this surface and this surface parallel. Okay? And I'm going to add that. So we've inserted a part into a part. You can see the feature tree now. We've got a part file sitting there inside of our part. So that's the key. And it's got some other things going on. And then here's where those mates or constraints or move copy body features are contained right there.
Okay, on the assembly side, creating the feature is pretty much the same thing. I can just open up the part. Same thing, I've got a library feature, I can drag it in, or in this case I can just unsuppress what I did, but it's the same thing. Drag it in, hit the origin, hit the right plane, I now have it in the part. And I'm going to suppress that. Go back to the assembly. Now I need to bring in the handle. Okay, we can all do that. We can take the handle, drag it in from our library, put the same concentric mate on the pin, put a mate between the right plane of the handle to the right plane of the box top. That's very beneficial, have all those planes lined up, easy to pick them. The one thing I can do that Phil can't at this point is I can do this. He has no way to do that, which makes it a whole lot easier when I need to animate this later because I have the degrees of freedom left to be able to do that. Okay? Now the next thing we have to build in here is we have to bring in that latch, and that latch is going to require a boss on the bottom part in order to snap that latch into, and then it's going to require a wedge on the top part so the latch can reach over the top of the wedge and then go over center. Now to do that, I have already brought in the subassembly, and it's out here floating free. I'm going to use it as a guide to create the boss. And the way I'm going to do that is, first thing I'm going to do with this latch, and there's my latch, I'm going to take the right plane of that latch and the right plane of the bottom box, add a mate, and that just puts it in like that. If I go to the right view now, right view, I can take this latch and position it. Now if I look at it this way, it's got to stay centered because it's on the right plane. But what I'm going to do is use this as a guide. So I know it's got to have a little separation from the side of the box, so I can position it wherever I need it. One nice advantage when I'm in an assembly, if I want to hide a component, I can just put my mouse cursor over and hit the tab key and I can hide.
He's showing off again.
Of course. Just to make sure we know what we're looking at here. Notice there's this through pin right here. Okay, that's what's got to be caught by a boss on the bottom. So that pin is going to have to go into a slot, and then the latch will pivot on that point. Okay. So let me just go backwards in my view here. View, go backwards. I don't have it there. So we know this has got to be down a little lower, so it's got to be down here someplace. Okay. So all I'm going to do is position it, and then I'm going to use that just to help me determine where the boss has got to go. So to do that, I'm actually going to go to the next set of files. Where am I going? Go to 4. Okay. Because to build it's just a little tedious, so you don't want to watch me sketch. And I go back over here to the... Come on, go right view. And now if I section this, you can see what I've done. Okay, so here's the little boss I created in the bottom part. Now what I did when I created this boss, I just sketched around so I knew I would capture the pin. And once I sketched around it, I went in and hinge tail latch. Am I getting the right part? Otherwise this isn't going to look right. Latch tab. Okay, so there's the sketch. So I used it, sketched around it, normalized the dimensions so I didn't have something really weird in there, and extruded it. And then made another sketch to make the cutout. So there's a sketch to do that. Now at this point there's no relationship between that latch and the bottom of the box. But it gave me a good guide to make sure I got this cutout in exactly the right spot. Once I've created that, now I can go back in and add a mate between this pin and the slot. So once I've done that, oops, this latch is now going to move in that, based on that pin. From there, it's just a question of going in and editing the top. Same idea, created a sketch. There are no relationships between this boss and this latch. So that's how I created it. Phil's got to do it a little different.
Okay, so we need to bring this same exact latch assembly into our part. Well, we can insert a part into a part, but we can't insert an assembly into a part. So we first got to open that latch and turn it into a part. That's how we're going to get around that. So let's just open up the latch. And that's the part. So I'm going to open up our assembly. Hang on. I'm a little lost right now. There we go. So here's the same assembly that Jim just brought into his, but we can't use it as an assembly, so we got to turn it into a part. So I'm just going to do a save as and turn it into a part. Okay, it's going to save all the different components into a multi-body part. And we need to pick this bottom choice. The first choice gives you only surfaces. The second choice is if you've got a more complex assembly that's got like stuff on the inside that you don't care about and stuff on the outside, you can just pick the outside stuff. But since this is such a simple part, we're just going to pick all of them. And we're going to save that. And we're going to end up with a part that looks like this. Okay, so we've got multi-bodies of all the different components that were in our assembly. But we're in a single part file now, so now we can bring that into our other parts. So let's do that, and I just moved the SolidWorks screen so it's not lined up anymore. Okay, so now we're going to go back to our part 5, and we're going to insert that latch. And I've actually got it in here already, so let's just cheat. So here it is. And when we brought it in all the bodies. Okay? Now, the difference is I positioned it with the constraints like you saw before, but I can't make that lower boss and then remate it. In other words, he could make the boss and then remate his part wherever he wanted to because there wasn't any order in the assembly mates. But we have features here, so we bring in the box latch and then we create the boss, and I can just show you how he did that. I just brought in the bosses. I actually did the top one first, so let's bring in the bottom one. So we've got both of those guys brought in, but I can't move my box anymore, I mean the latch, if I based it on that. I can't move, what am I trying to say? The latch is in a certain place, I built the boss around it, and now I can't move the latch because the boss will move too. So we're kind of in a slightly different situation than Jim was in because he can, once he builds the boss, he can move the latch wherever he wants, and we can't. So we're kind of stuck with it right where it is. But that's okay because we can't do dynamic assembly motion anyway, like he can. Okay, does that make sense? Clear as mud? Yeah.
On the handle, what happens if you just leave out that parallel constraint?
It will actually stay right where you left it. It won't let you move it either. No. I just put that last parallel on the handle just so it would behave, but it's not going anywhere anyway. But I just didn't feel it should stay straight up like that. That's one of the major differences. You get dynamic assembly motion in an assembly, but in the parts you have to settle for some other things. We do have a few ways to make it look different, but it's not dynamic assembly motion. Okay, now we're going to bring in the printed circuit board. So let me show you how to do that, because that's just another part. So here we are. Let me hide these two bodies. I can at least do that, okay? And here's the inside of our multi-body part. I'm going to insert another part. And actually, I've already got that in place too, so why don't I just unsuppress that? So we've inserted it the same methods we used before with the constraints. But we don't have any standoffs to hold it yet. We don't have any mounting bosses, okay? So that's the next thing we got to do. We got to put a mounting boss in this. So that's another fastening feature. Okay. New for 2013, they've added some methods or some types of mounting bosses. But it kind of acts funny. Right now, if we're adding one, you can see there's a bunch of choices here, right? Okay. But if you're going back and editing one, like this one, so I'm going to unsuppress this mounting boss I did previously, and if I edit that, you can see some of your choices are gone. It's kind of like when you do a thin extrude. Once you do a thin extrude, you can't turn it back into a regular extrude no matter how you try. The mounting boss seems to work the same way. Okay, so you get more choices in the initial feature, and then after you decide on which one you want, now you're stuck with that. Within this feature, you can always delete the whole thing and start over. Okay, so we've got this all set up to meet these meet the holes in the circuit board. Okay, now remember we said the circuit board may change size. Okay, so we're going to have to do a couple of tricks to make sure these mounting bosses stay in line with the holes with the circuit board. Okay, so we've got our first one in, but now we have to do a pattern of our mounting boss. Well, that's the way I decided to do it. So what I chose to do is go way out to this circuit board. Now if I want to jump out to this part, now remember we're in a part file, so we've got to jump out to this other part and look at it individually. You can't just edit the part. The edit of the feature would take us back to when we inserted it into the part. What you do is you do edit in context. And that takes you out to the actual part file that you just inserted. Okay, and all I did is I added a sketch here on these 4 holes that represent with 4 points, sketch points. And then when we go back into our box, those are still available here. They're right here under sketches. There's the sketch we're talking about, so I'll show that. And then I just use that to make a sketch pattern. And now we've got our 4 mounting bosses. We followed that sketch pattern in this printed circuit board. And that way, if we change the size of the board, our mounting bosses will follow it. It's kind of a convoluted way to get there, but it's one way to get there, okay? Then we have to add some other components. We need thread inserts in those bosses because we're going to screw this down. So I just inserted some more components, insert part into part. I brought in some inserts, and they're kind of hard to see. Let me just, I can make this lower body transparent. Just come up to our bodies and find the bottom. Where did it go? Right there. And make him transparent so you can see the insert I just added right there. And then I'm going to also add a washer and a screw. And these are all parts that are just on the drive. I mean, they're separate parts, but we're bringing those into this part. And then I did the same thing. I used that same sketch pattern on the printed circuit board to do a pattern of this, because when we did the mounting boss, it was the pattern of a feature, and now this is a pattern of a body. So they're two separate patterns. So I'm going to make a pattern of that. When SolidWorks does a pattern of a body, it uses the move copy, and it gives you an extra set of screws and washers and all that. So I actually have to delete one so we get the right part count. So all I did is take one set of those, the two that were overlapping, and I got rid of them. You'll figure that out when you go to make a bill of materials of this. So that's how we had to get to that point. We've got all the components in it now to hold the circuit board in, and they're all tied to that sketched pattern on the printed circuit board. Does that make sense? Still rooting for the multi-body side? Okay. Well, okay.
We're not done yet.
Sure. You could, but the things below it in the tree would follow it. So in other words, your boss would follow it. What we can't do is make the boss independent and then position the boss. Well, I guess we could have. It's getting complicated, but yeah, we could move it. We can't edit those. You go in and you edit the features. So in other words, where did it go? Latch. We could just go down here and edit this feature, and we could get back to those same mates and see we can change them any way we want. So in a way we can move it, but you just got to remember the latch in this case is before the boss. So whatever you move, it's going to affect the children. I guess that's the way to think of it.
My turn?
Yes.
Okay.
I'm done for now.
Okay, and the assembly version, it's still going to be a fastening feature. We bring in the circuit board. If we were to look at this from the top, you'll see that the board isn't centered exactly. The position we were given was over here. What we want to do here is edit the bottom part of the box. We still got to work in the assembly here, but I'm going to take the bottom of the box and edit it. Bring in the mounting boss, and we get the same dialogue we had with Phil. We're going to tell it it's going to go on the bottom of the box. We're going to use the hole in the circuit board for two things. One, by selecting the edge, is going to control the position of the mounting boss on the bottom of the box, so it always lines up with the circuit board. The other thing we're using it for is down here to control the height of the mounting boss. So it's always going to go from the bottom of the box to the bottom of the circuit board. Okay. When we do that, you notice that there in this feature, it is an in-context feature because it's referencing other things. It also has a 3D sketch in it, which we're going to have to deal with later when we start breaking features. Okay. Now, that gave me the first mounting boss. I had to get mounting bosses under these other holes. The way I did that was just to create a sketch on the bottom of the box, used each of these holes as reference, and just put points there. So I got these three other points, and then I just created a sketch-driven pattern to move the bosses to those positions. Okay. So that was relatively simple. Once we did that, since I'm in an assembly, I went in and took the inserts, and there's just 4 inserts in here. Brought them in, mated them into each of the holes. There's what the insert looks like, and I don't know why it shifted over here. I just selected those. I didn't want to open them, I just want to show them. So they went into the mounting bosses, then put the same hardware in that Phil put in. So I should take all these and show them. So now we've got everything into the box. This was the point. Okay. Now, at this point, it's probably a good time to check something. We've been building this thing parametrically this whole time, knowing that this circuit card could change size. Well, it's probably the time for the moment of truth. What happens when we change the circuit board? First of all, if I change the circuit board size, the mounting boss is going to move. Hopefully they will. And then when I look at that, the next question is, can I adjust the box to fit? So the first thing we should look at is the printed circuit board itself. And it's a pretty simple part. Right now it's 10 inches long, and we were going to bring it to something like 8.5 inches. So if I do that and rebuild it, circuit board got smaller, all the mounting bosses moved with it, the hardware all moved with it, so that part's okay. The other thing we probably need to do is change the size of the box just to make sure it follows along as well. So we probably need to see the top of the box before we do that. And we should probably show the handle. Okay, so there's the whole box. So how do I change the size of the box? Well, hopefully that's all controlled by that very first sketch. If I want to make the box a little smaller, let's see, the circuit board got 1.5 inches smaller, so let's just take the box down to 10.5 inches and rebuild it. And if all goes well, the top follows it. And the hinge is still attached, and just for fun, we should also make sure that it goes the other way, even though I really don't want to change this dimension. If I make that 7, just to show that I can, it should change, and the hinge doesn't detach. So parametric design all seems to be in good shape at this point.
Okay, and obviously we can do the same thing. We can just double click on these things and they'll both change together. The one difference is to get the the circuit board to change. Come on. We have to actually edit. It's kind of blowing up now. Oh, I should have made it bigger. It'll work. We just a few more clicks, we'll get it to work. But the key thing I was trying to show you is that to change the circuit board, we can't double click it here. We have to edit in context and go out and change the circuit board. So let's jump out there and edit in context, get to the circuit board, and we have to change it here. So if we change it to, he went up 8.5. Let's update that, and then come back into our part. And update that, and now we're all back together. Okay? So we're both on the same page. We can both make changes parametrically, and everything's behaving just like we wanted it to.
Okay, now we start looking at the materials. You know that we can assign materials to each part. The parts I created don't have materials assigned. So I'm going to have to put some materials onto both the top and the bottom, and I'll show you a shortcut for doing that. The other problem here is this printed circuit board. It's got a material in here called custom plastic. Okay, if I open this up in its own window, and I look at the mass properties of this, evaluate mass properties. I don't have the full representation of this circuit board. I've got the substrate, but I don't have all the components on it. And it's not really one material. So we made a dummy material called custom plastic, and it's going to have to represent this board with all its components. Well, we still don't know the full weight of this thing yet, but we can assign it a weight. We can override mass properties and tell it the weight. But not only can I tell it the weight, I can tell it where the CG is supposed to be. If we look at the circuit board, the CG is actually above the board because most of the components are going to be on that side of the board. So I can do that over on the assembly side here because I'm working in the parts. Now the other trick here is we know that if to assign materials, I could go in and part by part by part add materials. But we have assembly visualization when we're in an assembly. We can make a column that's SolidWorks materials, and you can go into these things and There's a thing in here to say add a column, and you can define what the column is. In 2013, we can have additional columns. So here's the box bottom and the box top. Here's the column for SolidWorks materials. I can just go in here and say, oh yeah, there's the material. I put it in right here and just march down the list and throw them all in right here. Let's see you do that. You know, I don't know.
Question was, can you control select?
It doesn't appear because I lost the first selection.
Okay, so the tortoise is catching up with the hare because we can assign materials. So let's see how we do that. If we've got a separate body, for instance the top or the bottom, that we created inside of this part file, we could just right-click on it, go to materials, and make it liquid oxygen or something like that. But let's stick with polyethylene, right? Okay, so we can change the materials just by right-clicking on them and going to the materials right from here. So it's changing the materials right on the tree of the solid bodies, okay? We can also do it to the parts we brought in, but if you can't do it from here, for example, the handle. If we right-click on here, there's no material. So the way we have to handle the handle is we have to go out to find the handle, edit it in context, and then go up to its solid body folder and go, and there's a material because this feature was created internally in this file. And then we can change it to polyethylene. And then if we go back to our multi-body part, you can see if we go back up to the folder, back up to the handle, now there's a material assigned to it because we brought it in. When we brought it in, it took on that.
That would change the original file for the
It did change the original file. But then it was linked, or the other part was, yes, linked into this file. And they will have the same, yes. Now, this is where Jim starts to do things that are just impossible for me to do. It's important to note that he was able to change the CG of the printed circuit board. We have not been able to find any way to change the CG of the individual bodies. Now, maybe you could make another body and hide it or something like that, but there's no direct way to just override the material properties, okay?
Okay, back to me. Okay, one requirement I have that Phil doesn't have is I have to create an animation of the box. So I'm going to do something like this. We'll show how the latch opens, how the box opens, how the screws and washers come off, and how you lift the circuit card out. Relatively simple.
Notice how conveniently that wasn't one of my deliverables?
Tried putting it in there and it was kicking and screaming, so I couldn't do that. Okay, this is where things start getting interesting, because if you go back to the first time I got to build the first parts of this box, we created the top of the box in context. And when you build things in context, you start talking about, you say, okay, well, the size of the top is always going to be the same as the size of the bottom. But that's dependent on the top of the box sitting on the bottom of the box. And when we created that first part in context, a mate was added in here called in-place mate. Basically, when we picked that front plane, it smacked the front plane of the new part right on the front plane of the bottom part, and that's what it expects to see. So I've got two problems. One, if I want to lift the top of the box, I got to get rid of that in-place mate. And the second problem I have is what's going to happen when we hit a rebuild and that top of the box isn't laying on the bottom of the box? Because remember, we converted entities. That meant it's the sketch is going to look normal to the sketch plane and see those other entities. The top is back here, it's going to see a very odd shape. So there's a couple of things we're going to have to do in here. To take care of the in-place mate, we're going to suppress it, but I'm going to replace it by a concentric mate and a coincident mate. Or I could have just used a hinge mate, but the concentric mate just lines up the cylinders here, and the coincident mate just takes the right plane of the top of the box and lines it up with the bottom. Okay, so that will allow the top to move. But, and there's a big note in here, don't do this yet because bad things happen. You have to lock the references. And if I make the mistake in here and try to do that, you'll hear Tom Hanks saying, Houston, we have a problem about 15 times and SolidWorks won't let me do anything. So you see all these external reference signs here. We have to lock all those references. Either that or get rid of them. So if I go in here and say, where am I? Come on.
List external references.
Down from the bottom. It's always amazing how you can't see some of these things when you get in front of a crowd. Said, okay, these two parts have external references. We can lock them all. And this was, I think, new in 13, where you could just do it from the top of the assembly. I hit lock them all. It's telling me they're all going to be locked. And you notice now I have the little asterisk. Okay, that's required because now when I hit rebuild, it's just not going to rebuild those dimensions. They're just frozen. Okay. So if I've done all that, then the next thing I should be able to do is create the animation. But there's one other oddity in here. This latch was a subassembly. Okay, and I need to move part of the latch relative to the other, so when I lift the bottom, the top's got to be able to slide up and pull back. I could make it flexible, but if you learn about animations, flexible mates are really a hog when it comes to rebuilds. So all I did was dissolve the subassembly for the animation here. The rest of the animation was done just by putting an angle mate between the handle and the top of the box, an angle mate between the top and the bottom of the box, and two angle mates over here on the latch. One to control the top relative to the bottom, and one the bottom relative to the box. And when you do all that, you can go in here and just throw in the key points, let it rebuild, lift the handle up with one mate. This is just two mates working side by side. Box opens, and then it's just a couple of key points to lift the screws, washers, and circuit board out. So relatively straightforward. Okay.
Okay, so did we mention Jim was a real whiz at animations? Anyway, we could do something equivalent. We're not that far behind him. All I'm going to do is I'm going to add some configurations. I'm going to add an open configuration that shows it open, and I'm going to show a closed configuration. So we can get the end result, we just can't show the stuff in between, right? And it was just as easy as adding a feature, move copy body, and we just picked the two bodies we wanted to move and told it we wanted to rotate it, 75 degrees or whatever. And we've got our two configurations. We're not interested in all that in-between stuff. We just need to show it open and closed. So we're doing just fine there. In addition, since our latch was all pretty much at the top level, we can control everything just from this top level. If I wanted that over center latch to open up, that would have just been one more move copy to tilt it over a little bit. Okay?
Okay, next thing we want to look at is drawings. Relatively easy here. Most of you should be able to make an assembly drawing. Since I have an assembly and I've got individual parts, I can do that. Even with the in-context features in there, it still doesn't change anything. Because I've got all my materials in here, I can add a column to the bill of materials. I can also fully define each part as necessary on additional sheets or additional drawings. So nothing really big here.
All right, so this is where it gets a little tricky. We can do a drawing too, and we can get a bill of materials, and I'll put parentheses around or quotation marks around that bill of materials. Here's my drawing. It kind of looks the same as his drawing. We've got something that looks like a bill of materials. We've got balloons. We've got exploded views. We've got a second sheet that has an individual body on it that has dimensions on it. So we can get all that right within the multi-body part and the drawing. The difference is this isn't a bill of materials. This is a cut list. Okay, so we take our multi-body part and we go up to our solid body folder. And before I created this file, the solid body folder was actually there, visible. But I had to make this a weldment, so I just said insert weldment. and we're not going to try to weld the circuit board to the plastic. We just did that so we could get a cut list out of it. And it's just like when you're working in a weldment, it combines like parts. So it combined all the screws together, combined all the lock washers and the inserts, such and such. Okay, then the secret is we went in here to each of the cut list items, and we went to the properties of that cut list item. Okay, now this is a little bit different. This is talking about custom properties, but it's within the cut list item. So it allows you to edit them slightly different. We can actually go to these properties summary tab, and these are the custom properties that I have assigned to all the different all the different cut list items. Okay, so let's say description is the one we want. It's showing you all the cut list items at the same time and all the descriptions at the same time. So this is just a different way to rearrange the custom properties within this file. And I just typed in the name. Same thing with the part number. I just assigned a cut list item called cut list property called part number, and I made up part numbers for all of them. And then when we got back in the drawing, I just changed the cut list so it had a couple of extra columns in it and hid a few columns, and now we got something that looks like a bill of materials, right? So we can get that. It's all parametric. It'll keep up to date, but it's just based on a cut list instead of a regular BOM. And then we can do the exploded view the same way. We can just explode this just like we always did. Just come out here to our configuration, explode it, and get that way. We exploded all the stuff at the top level. Okay, so now there's one more thing I want to talk about, because we've taken this multi-body about as far as we can, okay? We need to talk about what if you have to do animations, what if you have to make sub-assemblies, what if you have to do things like that. Okay, the way we're going to do that, let me just show you the finished product. And actually I want to close all. And I'm going to open another assembly. Okay, this is our assembly that I just created. The way we created that is we went out to the part, and for the very last feature, now when you say save bodies, we come up here to the solid bodies. The first thing you need to do is rename all your bodies so they're the same as you want the file names to be. This is the easiest way to do it. Go through there first and rename them all to whatever you want the file name to be. And that'll stick. That won't disappear the next time you work on the body. Then you just come up to the top of the body folder and you say Save Bodies. Okay? That inserts a feature called Save Body. Looks like this. Okay? And it converts all of those body names you just created into file names. It saves it out, and it allows you to create create an assembly to push all the parts into at the same time. So it's saving out all the bodies as individual part files, and it also creates the assembly to go with it. It puts all the components in the proper location, and they're fixed. Okay, so you end up with this. Now, once we do that, we can make a real bill of materials. And it's going to go just like, the part number is going to be the file name, and the description is going to be a custom property you add to each of the part files. So now we've kind of taken all those multiple bodies and we've pushed them out into the assembly, and it's used a bunch of fixed relationships, okay? But you don't have to keep those fixed relationships. In this case, I've taken and I've added some mates, and I can actually open and close this now. Right? So it's an assembly now. So now we can do whatever we can usually do in an assembly. I can even move this guy back and forth. Okay. Another thing we can do is we can create sub-assemblies. In other words, I'd probably want to create a sub-assembly between the bottom of the box and those inserts. Well, that's what I did. So if we isolate this, where's isolate? I know it's here somewhere. So there's our sub-assembly with our bottom of our box and our threaded inserts. Okay, and then the last thing I did is kind of optional, and I've used this successfully through a fair number of projects. I actually brought in the master model. In other words, that multi-body file is just hanging around out on the drive, right? We have to keep that around. We cannot get rid of that or this assembly will just fall apart. That is the parent to everything, so we have to keep it around. Well, where's a convenient place to put it so you'll always know where it is? Why don't we just bring it into the assembly? This assembly that we just created. And now if we ever have to edit it, we can edit that part. It's right here in the assembly. It'll update all the shapes of the multi-bodies, and that in turn will update all the shapes of our separate parts that we just used.
Did you virtualize it?
Well, I didn't virtualize it, but I turned it into an envelope. And then it doesn't appear on the bill of materials. And that's new for 2013 too. You can turn any part into an envelope, including a multi-body part. So if we look at this right here, and we isolate notice it's got this little piece for an envelope. I'm going to show that. And then so you can see it's the ice cube color that an envelope normally is. And then I can actually edit that and open it right from the assembly. Go back to the assembly. We can isolate that. Show just now we're just looking at the envelope, which is our multi-body that we've been working on all along. It almost sounds like a circular reference, but it's not.
What advantage does that have over just suppressing that model?
You mean turning it into an envelope?
Yeah.
Well, it doesn't. Suppressing it would be the same thing, but when you suppress it, the parts can't rebuild because they're based on that model, so you really can't suppress it. Well, but it's on the drive too, so maybe you could suppress it. But it's just cool to be able to turn it into an envelope. You know? Because you couldn't do that before. Virtual would cause all kinds of problems. Yeah, I wouldn't try to make it virtual. The other thing you probably didn't notice, sleight of hand, is that when I wrote out all those parts, and this is probably going to kick us over, I'll say it real quick. When you write out all those parts, we're writing out the handle again, we're writing out the latch again, we're writing out all that stuff again. And so now we've got the original handle and we've got the one we wrote out. So you've got some problems there. So you might want to go into the assembly and swap it out again and get the real parts in there. So you've kind of created a mess, but it, you know how it is. The meeting was in 2 hours, guys, remember? We made it. It's only been an hour and a half.
Okay, you show them file, find references?
Oh, yeah. Well,
Okay, the last thing we have to do is just break all the references on my side. But just to show something interesting here, if you do file, find references, it tells you where all the files are that your assembly's looking at. Okay, so here I am on the assembly side. And the really only references we have are right here, because the assembly is referencing has got the bottom box, which references back to the assembly. So we got 2 of these. Everything else are just separate parts. This indentation is just because it's a subassembly here. That's the whole list. How long's your list, Phil?
let me scroll down a little bit here and see what happens.
Okay, so we see a little difference here. Okay, now I have to get rid of these references, and you've got a couple of choices. We're going to kill the parametrics here, and we're either going to kill them permanently or we're going to think about resurrecting them. Now, to kill them permanently means I'm just going to take this assembly, I'm going to go into the parts that have the references, and I'm going to blow them away and replace them with something internal to the parts. Okay? The alternative is to save those parts out as copies. On the copies, blow away all the references, and then go back to the assembly and do a replace component. And just bring them back into the assembly without the references. And if I do that, all those in-place holders will go away. Okay. Since we're just about out of time, I'll just show you what happens here. Where are the external references? It's really the box top, the box bottom, and this equation folder. Yep.
Jim, could you ever use derived sketches to help maintain some of your relationships?
Yeah. Wait, yeah, but the question is, if I have to make everything separate in the end, then I have to do something with those derived sketches, because now I've created another link that I want to get rid of.
Right, but you just eliminate the derived sketch, it becomes a copy, but maintains the sketch dimensions and relations, so you don't have that additional work to do.
Okay, sure. I mean, you saw a couple of choices I made going through this that Yeah, we could have shared sketches in certain places, we could have converted in different places, but we made a conscious choice based on what we thought was going to have to change parametrically and what we were pretty sure wasn't going to have to change. Okay. I've got a link up here in the equations. How do I get rid of that one? If I just delete the equation, it goes away. What happens to the radius for the upper part? It's whatever it used to be. It's just a hard dimension at that point. I could then go into something like the box top. Where are the problems here? I got a lip and groove. That's a problem. You can't just suppress this thing. You can't, as a matter of fact, if you try to edit this, where's it going to go? It's got to go back to the bottom. The only way I figured out how to do this is I'd roll back before this point, or actually just before the lip and groove, go to the right plane, open a sketch, do a section view so I can see what I'm doing. On that sketch, what I did, I created a sketch that went from this point to this point to this point back to the bottom. And I made the sketch without creating references, which you can do in your tools, or if you create references, just blow them away and just hard dimension this and sweep the cut. And once I do that, I can go out and take the lip and groove feature and just delete it. So I've used what the lip and groove feature to actually create the geometry I needed. Now I just copied over it and then blew away the original. Okay. The other thing we can do in here, where's the problem? This boss feature here. The original sketch, get out of this sketch first, and the tools you use all the time here. You know, what's the relationships on this? They're all on-edge relationships. So I could go into the sketch, display, delete relationships. If you go in here, you can choose, say, just defined in context. Delete them all. Now what do I do? Well, that's where that other tool that's in here comes in handy. Let's get rid of this. Fully defined sketch. Tell it to calculate, say, yeah, that looks pretty good right there. Now fully defined, get out of the sketch, and I no longer have a reference there. Fully defined sketch, great tool. Okay. Also, just remember that when you display delete relationships, you can parse the list by all the relationships or just the ones in context, blow them away. Okay. Bottom would be very similar to that. So with that, we'll hit the summary and be done.
Okay, so, we're going to go straight to that one?
Yep.
Okay, we're going straight to that one.
Yeah, that's
No, you're at the very end.
right here. No, that's this one. Go forward. Go the other way. The other forward. Keep going.
We've got a very nice script here that I'm not following.
When
Anyway,
all
all
else
this
fails,
stuff-
read the instructions.
Okay, so I promised you that I'd answer this question right at the beginning, right? Well, the answer to the question is... Okay, and I think you'd all agree. Anyway, we had a big summary planned here. We've done some modeling differences. This will all be in the file that's available, but we're 3 minutes over. Even though the party doesn't start till 7. You don't have to be on the buses till 7, but still. I used a single part file. I used separate bodies. I had to pay attention to what I was merging and what I wasn't merging. I used the master part technique with not the split feature, but we used the save bodies. You could have also used the split feature, and the bodies could be saved later in the assembly by, using the individual parts.
I use both the top-down, bottom-up modeling together. You saw the problem with the in-place mate, internal, external parts, locking and breaking in-context features. You have to consider the far end as you're creating them and going through.
Also, we saw different ways to sharing sketches. We saw the use of the library feature in both the individual parts and then in the multi-body. We inserted parts into parts. We positioned them using move, copy, rotate as the actual tool it used.
Two different things we did with sketches. When I did convert entities, I have a parametric relationship between sketches. When I copied sketches, I didn't. Still use library part. Inserting parts, I had the advantage of being able to control all 6 degrees of freedom very easily.
Also, real quick, the mass properties, you saw the problems there. I could keep up with them for a little bit, but as soon as you started messing with the CG, overwriting the CG, I couldn't keep up with them.
And the one thing you may or may not have realized before is using assembly visualization to be able to add properties to the file, so you have them all in one table.
And then finally, we saw the difference in cut list, BOM. We saw the difference in the breaking the end top, the lip and groove, that's really a feature that's really hard to deal with. The lip and groove. If you've got a simple part, you may want to just skip that and just do it with regular features because it's really hard to break the stuff. We couldn't bring the latch in as an assembly, but we could save it as a single part file with multi-bodies, and then we could bring that in. Couldn't do assembly motion at all. And one other thing, the hole alignment tool for checking the alignment between two hole features, when you talk about a base part and a derived part like we did, in other words, in my assembly that I ended up with, if I wanted to use the hole alignment tool, it wouldn't have worked at all. It only works in the parent stuff. It would look like you don't have any hole alignment problems, but it just wouldn't find them. It's in the help file. It says this is a limitation of the hole alignment tool. It won't work on multi-bodies where you save the bodies. So be careful of that.
If you've got to make an animation, do it as an assembly, and then we saw the problem of external references of locking, breaking, removing them. So with that...
That's all, folks.
Not too far over. We're good there.
Thank you very much.